Hi guys, in our last video, we discussed naming polynomials and how to write them in standard form. Today, this lesson is going to look at how we can add polynomials together. We're going to do that by combining their like terms, which leads us into the first thing we're going to need to review is what are like terms? Like terms are terms that have the same variable or variables, if there's more than one, with the same exponents. So you did learn this in pre-algebra. We talked about it earlier this year, but I want to discuss this before we move forward to make sure that everybody understands like terms. So in this chart, you can see examples of things that would be like terms and examples of things that would be unlike terms. So if we look at the like terms on the left, x squared and negative 7x squared are like terms because they both have an x that has an exponent of 2, x squared, which means we would be able to add those together. X squared plus negative x squared would be negative 6x squared, or we could subtract them. X squared minus negative, which turns to plus 7x squared, we would get 8x squared. The like terms allow us to add and subtract terms. If they're unlike, then we cannot add or subtract them. They have to stay the way that they are. So if we look to the right, we have an x to the fourth and a negative 7x squared. You can see I highlighted in red what makes them unlike terms. The first one has an x, and the second one also has an x, but the exponents are different. Both things have to be the same. The variable has to be the same letter, and the exponent with that letter has to be the same. So x to the fourth, x squared, those are unlike terms. If we look back at like terms, that second line, we have 2a squared bc, and then 5a squared bc. Those are like terms. They have the same variables, both have an a, and both a's have an exponent of 2. Both terms have a b, and both terms have the c. So those are like terms. On the right, if we take a look, 2a squared bc and 5abc squared are unlike terms. The first one has an a with an exponent of 2. The second one only has an a, which means that exponent is a 1. Those are different exponents, so they are not like terms. Each one has a b that matches, but then when we look at the c's, they're again unlike terms because we have a c to the first power in the first one and c to the second power in the second term. So they are unlike terms. They have all the same letters, but the exponents on those letters do not match. And then finally, the last row there, like terms, x and 3x. If I were to add those together, x plus 3x would give me 4x. If I were to subtract them, x minus 3x would give me negative 2x. On the right, I have 3x and I have 3y. The number in front of the variable, remember, is called the coefficient. The coefficients are the same, but that doesn't matter. Like terms don't say anything about the coefficients. It talks about the same variable with the same exponent. Well, these two have the same exponents of 1, but not the same variables. This has an x, that has a y. Unlike terms, we would not be able to add or subtract those. So let's take a look at how we use this information. Add the polynomials, and as always, write your answer in standard form. So if we take a look, we have 12y to the third plus y squared minus 8y plus 3 plus the quantity 6y to the third minus 13y plus 5. So we have two polynomials being added together. Before we actually add them, let's review naming. If I look at this first polynomial, I can see that it has a degree of 3. Remember, that's the highest exponent. And it has 4 terms. So this one would be a cubic polynomial. And then if we take a look at the second polynomial, the one that's being added, that one also has a degree of 3. The highest exponent is 3. And it has 3 terms. So this would be a cubic trinomial. So we have a cubic polynomial plus a cubic trinomial. So just some vocabulary review there. So let's get into how we're actually going to do this. Notice that I made this plus sign in the middle. Notice that I made that green. That's where you look to see if this is an addition problem, a subtraction problem, or eventually we'll get to multiplication. It's the sign that is in between the two polynomials. That's what tells us what type of problem it is. When it's an addition problem, we can remove the parentheses without changing the value of it. Adding, if we take those parentheses out, doesn't change the problem. We can do that, we're allowed. So the steps we're going to take for an addition problem, step 1, we're going to remove the parentheses. So we'll rewrite the problem without the parentheses. Step 2, we're going to look for any like terms that we can combine. And step 3, we're going to make sure that our answer is written in standard form. So let's go ahead and do this problem. Our step 1 was to remove the parentheses. So I need to rewrite this without the parentheses. Our next step is to look for any like terms that we can combine. Some people in this next step will just write the like terms right next to each other. I like to draw shapes around mine and then I can combine them in the next step and not write that next line. So if I look here, I have 12y to the third. So I'm looking for another term that has y to the third. Y squared, nope. Y, no y to the third. I'm going to keep the sign with that term, just like we did when we were rewriting in standard form. I need to know if that's a positive or a negative 6 when I combine it with my other term. And I'm going to keep looking, just a y, no y. So those are the only two y to the third terms we have. So I'm going to go ahead and combine those. 12y to the third plus, that was why it was important to keep that sign there, 6y to the third. So 12 plus 6 is 18y to the third. They had to have the same variable with the same exponent because it stays the same in your answer. Y to the third plus another y to the third. You still have y to the third. Then I look at the next one. I have a y squared term. So I'm going to look through. That's just a y, no y, no y. So there's no other y squared term. So this doesn't change. It just needs to come down plus y squared. And then I can find I have negative 8y. So I'm going to look at what's left. There's no y there. Here's just a y. That's a like term. Negative. I want to keep the negative in the shape just like I did with the negative 8y. Okay, and this last term, no y. So negative 8y minus 13y gives me negative 21y. And then I have this term without a variable, which is called a constant. Remember that? When it doesn't have a variable, it's just a constant. So I'm looking for any other constants. I have plus 3. And here's another constant, plus 5. So when I combine those, 3 plus 5 gives me positive 8. Then I want to check and see if my answer is in standard form. Highest exponent to the lowest. So 18y to the third plus y squared minus 21y plus 8. So I have an exponent of 3, 2, 1, and there's no y, so that's an exponent of 0. So this is in standard form. That is my answer. Let's take a look at another one. Add the polynomials, write your answer in standard form. So first step is to rewrite the problem without the parentheses. Okay, so I'm making sure that all my signs are the same. I just dropped the parentheses. On this example, I'm going to show you the other way that I talked about on the last slide. Instead of drawing shapes and combining right away, I'm going to rewrite the problem, putting my like terms next to each other. Then in the following step, I'll combine so that you can see and then choose the way that makes more sense to you. So if I look through here, 7x to the third, I'm going to go ahead and write that to the third, and then use that. Do I have any other x to the third? No. So then I'm going to look next term. I have 6x squared, positive 6x squared. I'm going to write that and look to see if I have any other x squared. Here's one, plus 9x squared. That's down there. Any other x squareds? Nope. Then I'm going to come through. My next one is minus 2x. See if I have any like terms with that. I do. Negative 4x. 4x. No other like terms with that. And then the last thing I have is plus 3 to bring down. So I brought everything down. I just reordered them so that they are next to their like term if they have one. So 7x to the third did not have a like term. I'm going to rewrite that the way that it is. 6x squared plus 9x squared, those are like terms, becomes plus 15x squared. And then I have negative 2x minus 4x. Negative 2 minus 4 is negative 6. Be careful with those. Use the calculator if you need to. And finally, I have a plus 3. There's no like terms that change that number. Just so you can see where everything came from there. And then I want to check and make sure that my answer is in standard form, highest exponent to the least. So I have an exponent of 3, exponent of 2, exponent of 1, and no exponent, so that would be, or no variable, so the exponent would be 0. So that's in standard form. That is our answer to that problem. So now you've seen both ways. This last problem here, I'm going to do the way that I like drawing those shapes around them. So first step, we can go ahead and drop the parentheses, rewrite this without them. Now you'll see I wrote this, I brought the plus and then wrote the negative, but it's better to not have double signs that are going to get confusing and just make that minus 2x squared. Plus negative is the same thing as minus. So let's go ahead and combine our like terms. So I have a 2x squared. I'm looking for another x squared term. Well, there's one, and we said that's negative 2x squared. So 2x squared minus 2x squared, those two cancel each other out. We don't have any x squareds. We have 0x squared. And when we have 0, 0 times anything, even if it's 0 times x squared, is 0. So they eliminate, they go away. So I move on to the next term. I have a negative 4x. I'm looking for another term with an x. There's one. Negative 4x minus 5x gives me negative 9x. And then I have a constant of 4, another constant of 4. They're both positive, so they don't cancel each other out. We have 4 plus 4, which is positive 8 plus 8. And then I want to check and make sure that my answer is in standard form. Highest exponent to the least. We have x, which means that's to the first power. There's no x, which means it's to the 0. So 1 down to 0. This is in standard form. So we didn't do any examples where we ended up not in standard form, but if you do, then you just need to rearrange it like I showed you in the other video into standard form after you simplify. So that's how you add polynomials. In Google Classroom, there's a link to a quizzes activity. It's worth 10 points. There's 10 questions, 10 multiple choice questions. I have it open that you can retake it as many times as you would like before the due date. The due date is Saturday by 11:45 p.m. So you can retake it as many times as you would like before that. However, note that if you take it twice and you're still not happy with your score, then you probably should be emailing me or stopping into my office hours so that we can go over what mistakes you're making and correct it. I also want to point out, very important, right here. Sorry, I'm fighting with this a little bit. There we go. Right here, this note. Oh, that's not the note. Hold on, I'm sorry. This one. I already went over the note. This. You should be signed in using your student Google account with your first and last name. I know a lot of you like to put funny nicknames in there when we're in class. That's okay, but this way it's going to be very hard for me to tell who you are to give you credit unless you use your first and last name. Please, please, please make sure that you are doing that so that I can, give you the correct points that you earned in the grade book. So as always, if you have any questions, feel free to email me or stop into my office hours. And happy adding polynomials, guys.